Dear students, now we are going to discuss about the sizes of the cations and anions with respect to their atoms, and also how to compare the sizes of the ions carrying the same charge, both positive or negative, and like how the ionic radius increase down a column or a group. Let's take one example. So basically, we can consider sodium. So when you consider the sodium atom, so we have the electronic configuration 1s2, 2s2, 2p6 and 3s1. Well, now let's look at the sodium ion, the electronic configuration of sodium ion. So how would you write the electronic configuration of sodium ion? So the electron is removed from the outermost energy level, which is the 3s1. So we can write the electronic configuration of sodium ion as 1s2, 2s2 and 2p6. Now the outermost energy level is actually the second main energy level. In the previous instance with the 3s1, the outermost energy level used to be the third main energy level. Now what do you think of the size of this sodium ion and the size of the sodium atom? Compared to sodium atom, the sodium ion has less electrons. So it has less electrons. Since it has less electrons, and moreover, now this sodium ion has 11 protons, and this sodium atom has 11 protons, and sodium ion has 11 protons. But the difference here with sodium ions, the sodium ions have this positive charge by which the valence electrons are attracted more towards the nucleus because of the positive charge, as there are less electrons present on sodium ion. As a result of that, the size of sodium atom is greater than the size of sodium ion. So always regarding the cations, the cationic size will always be less than the size of the atom, the corresponding atom. If it is sodium ion, here it is a sodium atom. I hope you understood that. Next, we will compare the anions. So if we compare the anions, we can take another example. So we will just consider chlorine. So it's 1s2, 2s2, 2p6, 3s2 and 3p5. And then when it comes for Cl minus, so 1s2, 2s2, 2p6, 3s2 and 3p6. Now you can observe here you have 3p5, and for the chloride anion there is 3p6. Now if we consider the number of protons, we have the same number of protons, which is plus 17, here also plus 17. So the nuclear charge has not been changed, but there are excess electrons. Now here it used to have 3p5, now there are 3p6. So there are more inter-electronic repulsions when it comes for this anion compared to the neutral atom. As a result of that, the anionic size is always greater than the size of the atom. So that's what I expect. So anions are larger than their parent atoms, whereas the cations are smaller than their parent atoms. So parent atom in the sense, the neutral atom. And let's consider the ions having, that's a third example, ions having the same charge. So let's consider lithium and sodium. Lithium ion and sodium ion. So lithium ion, it has 1s2, and sodium ion, that's the valence configuration, is actually 1s2, 2s2, 2p6, 3s. It should have 3s1, but it has 3s naught because a cation has been formed. Now, what can we say about this? So lithium cation and sodium cation. Anyway, down the group, so lithium plus has 1s2 1s2 electrons, and that's it. So it doesn't have any more electrons. But when it comes for sodium, it has more inertial electrons, and even though there are the more protons compared to lithium, the inter-electronic repulsions are greater when it comes for sodium. So therefore, the size of sodium ion is still greater than the size of lithium plus ion. So down the group, ionic radius increase if they have the same charge. So I hope you understood this content.